Assalamu alaikum, dear students. This is Google Collaboratory. Okay, Collaboratory. This is an online compiler of Python managed by Google, and there is no need of installation. If you have internet connection, you can use it, and it is regularly updated, and there is no need of, I think so, libraries import or library installations. You can import library, but there is no need of installation. All libraries are regularly updated over here. Okay, if you are a beginner, then you can click on this button, getting started, and then data science and then machine learning assets. I just click on this feature example. These are some small, I think so, machine learning projects. Okay, and among feature examples, I just click on text classification. This is, a project called as text classification. Over here, it is started, the code is started, and these are the libraries that are needed in this project. One is numerical Python, TensorFlow Hub, and datasets of TensorFlow, and also for visualization, Matplot is PyPlot. TF, NP, Hub, TFDS, and PLT, they are the denominators. Okay. Over here, if you go down, there is another section, how to import the datasets from TensorFlow datasets. Okay, so you can also do it like this. Train data and test data, these are variable, denominator, and the same data. For example, IMDb review is assigned is used as a training and also for testing. Some researchers use separate data for training and separate data for testing. But over here in this project, they actually use the same, I think so, data. And there are two more, I think so, lines in this importing of data sets. One is a train example, train label, test example, and test labels. And the above imported or the import downloaded data sets, train data and test data are assigned to them. Okay, so let's go down. After the, you can print, I think so, the train data is how much, I think so, records in this data. Over here you can see like this. Okay, you can also train label, you can also specifically, this is the there are some good data structure in Python. They are used for splicing, I think so. From zero, this is the first initial parameter, and then the final parameter. You can, and this, I think so, specific statement will print the first 10, I think so. The first 10 records and that specific variable, train level. Okay, after that, there is a, you have to build the model. The model over here is already built, and it is, I think so, available online. This is a specific neural network. Okay, and it is in the TensorFlow Hub. TensorFlow Hub, we already actually imported it over here above. Okay, you may be familiar with this. These are variable, hub layer and model. These are variables. Over here, a hub is imported over here above. This is the TensorFlow hub. Inside the TensorFlow hub, there is a Keras. Keras is a sub-library. Am I right? And model, input shape, etc., etc. Okay, the training example, you can retrieve it. Again, this data structure is used. Am I right? So this space is empty. It means from beginning to up to 3. Okay, let's now build the full model. The full model is like this. TF, under TF there is another library, Keras, and inside Keras there are, I think so, sequentials. Okay, add a hub layer, and after that add TF Keras layer and dense. These are, I think so, the dense sequentials, etc. They are, I think so, the variant of the specific neural network or machine learning method. Okay, After that, there are some other description about this project's, for example, a loss function in optimizer, for example, what kind of parameter you have to use it for classifications. Okay, actually, this project belong to the the positive and negative comments about movies to classify the negative comment from those as positive comment. For example, good is positive, and for example, if you say about any they're disgusting or boring, then that may be classified as negative. So this model have to classify those, I think so, words. Okay, train the model, and it may, I think so, need some time. You have to train it. Okay, like this, there are a total of 40 approaches. You can increase or decrease it. There is no problem in increase or decrease of approaches. Okay, the term approaches actually come from in this programming side come from the history of life on planet Earth. The history of life on planet Earth, we describe it in different approaches. So this thing, the approach is also come in programming side. Okay, evaluate the model. You can evaluate it like this. Okay, and after that, create a graph of accuracy and loss over time. Okay, you can do it like this, history in these I think so commands, and at the end, this is accuracy, value accuracy, loss value. Okay, the success of this model, training and validation loss and loss, and these are the 40 approaches below. Okay, so this is specifically used for this purpose. There may be other visualization and other project, and in this model, this is, I think so enough. This can give you the negative comments and positive comments, this model successfully. And this, I think so, graph specifically, I think so, you can see over here, the training accuracy and validation accuracy. Validation accuracy is, I think so, low, the training accuracy. Okay, the same data is used for testing and training. So your questions are welcome, and I can help you and other items so project like this. So this is the way how to do project research project, specifically in programming side. For example, you can also change the code over here. You can also copy it. For example, if you copy it, you can over here paste it in the main compiler. This is the button to, I think so, write code. Okay, we can, I think so, run it over here. It will give a lot of errors because all the things over here, they are not defined. First of all, you have to sequentially write the code from top to bottom, from import of libraries and then importing the data set, etc., etc. Then there will be, everything will be okay, and you can see those graphs. Okay, thank you very much for this lecture.